Hi guys, it's me again. So you just finished simplifying some rational expressions, which should have been pretty straightforward. And now we're going to move into multiplying and dividing rational expressions. There really isn't a whole lot of difference here as we walk through. Hopefully you'll agree. So let's start once again with rational expressions that are monomial in nature. So something like 5m to the 6th n squared over 10mn to the 8th times 4mn cubed over 6m to the 7th n. Now, you have two options here, and it does not matter to me which option you choose. You can either multiply these two things together right away, meaning multiply the two numerators together and then multiply the two denominators together and then simplify your answer. Or you can simplify first, then multiply, but be sure to simplify your final answer. I'm going to go ahead and multiply directly across here. So I've got 20, 6 plus 1 will give me m to the 7th, and 3 plus 2 is n to the 5th, over 60, m to the 8th, n to the 9th. Now, clearly this thing needs to be simplified, so I will do so. Let's see, this will be 1/3. And I'll use my subtraction rule. 8 minus 7 is 1m remaining in the denominator, and an n to the 4th. Now, it's important that I have the 1 in the numerator as a placeholder, so don't lose that little guy there. And this is done. Let's look at another problem. Now, this one is going to be division. However, division turns into multiplication when you're working with fractions, so it's essentially the same type of problem. So here's my original problem. You want to remember that division of fractions turns into multiplication by the reciprocal, so I will rewrite this. The first fraction stays the same, and I'm now multiplying by the reciprocal of the second fraction. And now, just like the first problem, you can simplify first. I'm going to multiply across first. So I have 6, x to the 4th, y to the 12th, over 4, x to the 8th, y to the 7th, and I will now simplify my answer. And this guy is done. The one other thing I want to point out about division problems is sometimes the division problem could be written with a good old-fashioned division symbol, but it could also be written, I'll write one down here, could also be written as sort of like a complex fraction, like this. And it's the same thing, doesn't matter, the top fraction stays the same. And I multiply by the reciprocal of the fraction that's in the denominator. And so, just as before, we can multiply straight across. And then simplify our answer. Looks like the m's are gone completely. And there it is. There's not a whole lot more to say about this particular type of problem. When you're working with monomials, you simply have those rules about multiplying, you add your exponents together, dividing, subtract the exponents, and make sure that you remember that division is multiplication by the reciprocal. I'd like to move on to multiplying and dividing rational expressions when we have polynomial factors. So, let me switch this up, and here is problem number 4. Now, the deal with multiplication when you're looking at problems like this is that we're not actually going to multiply. So don't get carried away. Let me write this problem down. Hold on. Okay, In the problems that we just looked at, we actually multiplied across using the rules for exponents to simplify. Now, this is a different situation here because now we're looking at polynomials rather than monomials. I have trinomials here. You don't want to actually multiply this stuff out. It's just going to turn into a big mess. We're looking to simplify the situation. So what we're going to do here is we're going to factor anything that we can possibly factor. So I'm looking at the numerator and I'm asking myself what multiplies to 18 and adds to 9. So that will be a 6 and a 3. And then in the denominator, same deal, what multiplies to -4 and adds to -3. Feel free to pause me at any time if I'm going too fast. I'm going to keep going. Okay, I've factored everything that I can factor. Now, what I'm looking for here are pairs of common factors that can be eliminated. One has to be in the numerator, one in the denominator. They can be within the same fraction or in two different fractions. So, for example, there is an x plus 3 in the numerator of the first fraction and an x plus 3 in the denominator of the second fraction. Those can cancel out. There is an x plus 1 in the denominator of the first and an x plus 1 in the numerator of the second. Those can cancel. There's an x plus 2 in the numerator and an x plus 2 in the denominator. Those can cancel. All that I have remaining is x plus 6 over x minus 4. That's it. This guy has been simplified. All right, you're going to try the next one. So again, you're going to write the problem down. You will pause me, attempt the problem, and then watch the solution. All right, pause me now. In the numerator here, I can see a common factor of 2x, leaving me with 3x minus 4. Difference of 2 squares in the denominator. This will be x minus 7 and x plus 3. There's another difference of 2 squares in the denominator. And now I'm going to look for my common factors. Here goes. I have a 3x minus 4 and an x minus 7. And I think that's all that's remaining. Here is my simplified expression. Let's do another one of those. I'm going to change this numerator to 16. Okay, so once again, pause me, factor, and simplify. So here is your factored form, and we're going to look for common factors now. X plus 4. Oh, this little x right here. This x and this x, but not the 10. Leave the 10 alone. And I think that's it. Now, I can't cancel these x minus 5s because one's in the, they're both in the denominator. I don't have any in the numerator to cancel. So in final form, here's what's remaining. Sometimes not a lot cancels. That's okay. All right, now recall that division is the same as multiplication. It starts off looking like a division problem, but we change it to multiplication by the reciprocal. So I'll walk through one problem like that, and then you guys are going to work on some. So here is number 7. So again, starting off looking like a division problem. But when I factor it, I'm going to go ahead and flip it over. So I'm going to do the factoring and the flipping of the second fraction in the same step. So this one will not flip over, so I'm just going to factor it. So x minus 4 and x plus 2. And then over here, I'm looking at x minus 11 and x plus 2. And that's going to get multiplied by, this guy's going to move to the denominator. And this guy's going to move to the numerator. And now I'll look for my common factors, x minus 11, x minus 4, x plus 2, and here's all that's left of this one. And it is simplified. All right, so rewatch as needed to make sure that you understand the process, and then you will have a worksheet that has some of these problems on it. All right, see you soon.